Alright, time for another draftphysics.com, debatephysics.com also. Video presentation. So, this series of videos started with Steve Mould's video where he claims, okay, that there's some reason to believe and there's some science to back it up, and that he certainly didn't prove it, but anyway, that somehow you don't have to conserve momentum. Levers don't conserve momentum. Pulleys don't conserve momentum. Nothing conserves momentum. The simplest tools don't conserve momentum is his argument. So he's basically stated overtly that if I put a certain amount of momentum in one side of a lever, I won't get the same momentum out the other side. Somehow it'll magically conserve the kinetic energy. So if I use a 2-to-1 ratio, mass ratio at twice the distance, obey the law of the lever won't work. So even though it's 2,000 years old and nobody complained about it until now, pretty much, right? No one was said, hey, the law of the lever is garbage. They're saying it now, all right? And you would think somebody would have observed that momentum isn't conserved somewhere in all of this physics. So obviously my assertion is that yes, the same momentum in this side force-wise is going to give you the same momentum out the other side. It's a weight, it's a pressure. It's going to have to be conserved. You can't leave with 1.4. If I exaggerate this and did a 4 mass here and a 1 mass, 4 units of distance, they're arguing that half the momentum is gone. Just silly, frankly. It doesn't happen, okay? So if I did make this into a balance, gravity balance, this won't go 1.4. It will go twice the velocity, indicating that's the velocity that keeps the oscillator oscillating. So it's just junk. It's garbage science. Video's got over 1 million views, and it's trash and rubbish and nonsense. It's not the truth, and they get away with it because everybody doesn't care about the actual physics. They don't care about the actual experimental evidence. So even though ballistic pendulums kind of prove over and over again that you can't collect kinetic energy, rocket ships prove it. You can't move a rocket ship with kinetic energy. So you can shoot thrust out the sides to navigate, or you can shoot it out the back. If you calculate the kinetic energy of the thrust, you could throw baseballs out. It won't work. It's just going to be about the momentum. So you could throw a baseball out one side and a bowling ball out the other side, and the baseball could have 15 times the kinetic energy. Won't matter. The only thing that matters is the momentum. Momentum's the only thing that obeys Newton's third law. So none of this matters. Those absolute facts mean nothing to these science people. People who are supposed to care about science. People who have maybe read a few books written by scientists. Maybe even read some Mendel or something. And this is what they do. They believe absolute nonsense for no good reason, just because it's written on the bandwagon that that's what they believe. So yeah, they like the banjo players and they like the free beer, and that's all they care about. They don't care about this thing with science. What is that? That doesn't mean anything. Evidence? We don't need no stinking evidence. It's a joke. I mean, it is the idiocracy version of science. And it started in 1693, 85, something like that. 85 maybe, 86. 1686, Leibniz just said 4 pounds dropped 1 foot is the same as 1 pound dropped 4 feet, even though the 4 pounds dropped 1 foot has twice the momentum. Who cares? It's the same energy. So something with twice the momentum can't do twice the work. That's their argument. That momentum doesn't do any work. That momentum doesn't mean anything in football or golf or anything. I was actually thinking of golf because when I played, I had I just picked up junk clubs. I'd buy one at a store. I didn't care about a match set or any of that crap. So I had a driver that was really old, and it was a foot longer, than my driver of preference. And but it was really interesting because if you could actually hit it straight, because it's a little hard, it's a foot longer, hitting a little ball, you really could get a lot more distance out of it because of the leverage and the fact that you kind of defeat all the facts that your muscles can't move fast enough. It's like you have a maximum speed, and that little extra length really gives you an advantage in being able to throw something faster than you would be able to throw it without that longer arm. And but yeah, so it was, if there was a hole where I didn't have to worry about landing in some horrible place, I could pull that out, and it was a lot of fun if I could hit the ball straight. Anyway, just an anecdote. Not terribly relevant, but just another. You give all the examples of where leverage, where you've used it in your life, and you've got to understand that this idea of mechanical advantage doesn't mean that you're making more energy. You're just converting it. You're taking big M, little v, converting it to big V, little m's. And that's all you're doing. You're just changing the size of those two proportionally, but you can never make more of anything. You can't make more power or more work or any of this crap. You always have to conserve it. And obviously you can't conserve both kinetic energy and momentum, and the lever proves you can't. You have to choose a theory. You have to say, this theory, one of them works and one of them fails dismally. And the truth is, kinetic energy fails all the tests. Every single time you convert energy from a light thing to a heavy thing, or from a heavy thing to a light thing, kinetic energy is going to give you a silly answer. And that's the absolute truth. All right. If you pay any attention, you'll notice it. But if you're a stupid, ignorant bigot, you won't. All right. Simple enough. All right. So that's the reason, yeah, Steve Mould still in these videos, is because this is million plus view nonsense physics. All right. And everybody, cares about science should notice, hey, wait a minute, that's just wrong. You shouldn't tell little kids that kind of crap, okay? That's child abuse, frankly. Preaching nonsense to kids? Why don't you let the religious, save that for the religious kooks. Scientists shouldn't be doing that. Anyway. Yeah. So, we're going to talk about springs. Relevant to silly experiments done by silly people. And we'll read some of their silly comments and discuss the subject of how energy is transferred between objects. And some of it is known physics, some of it is you have to deduce it. You have to use your brain and figure out, oh yes, it's a cause and effect universe. I have to isolate causes. I have to isolate events and variables. So anyway, I asked the stupid AI thing on Google whether kinetic energy, do springs store the equivalence of kinetic energy? And I asked them, do springs store the equivalence of momentum? And AI is a wussy and won't answer either question. It says no to both. So it says, no, a spring does not store the equivalence of kinetic energy. Instead, it stores potential energy. So we know the word doesn't mean anything. In some cases, there's no potential involved. It's, as my analogy, of a boat on the side of the Mississippi River. Are you going to say the boat has potential energy? Are you going to recognize that, no, it doesn't have nothing until you put it in the stream, and then it takes time for the stream to give it motion. And there's no potential about it. There's an active kinetic stream. And so it's like water wheels aren't converting potential. They're converting actual motion. Active energy. See, it's what they should talk about is active versus stored. And that might make so much more sense. But anyway, it's physics, so making sense, not so important. Anyway, potential energy, which can be converted into kinetic energy. Yeah, well, and so that's the whole argument here. Can I store it in a spring and then get back any amount of kinetic energy I want. Just pick a value and I can get it by putting the right mass in front of the spring. I'll get whatever kinetic energy I want. Okay, when the spring is compressed or stretched and then released. So yeah, we already know that part. Allowing it to return to its original shape. Well, that's really interesting too. And transfer the stored energy to the attached object as motion. So again, the stored energy in this vague term, it won't answer the question. So, and you know, they have these questions on all these other websites, these forums, and every time they just shut it down as quick as they can because, yes, it's circular reasoning. There's no evidence demonstrating the fact that you should believe in anything other than the conservation of momentum because it doesn't work. The rest of this kinetic energy theory doesn't show up in. There's no evidence in the evidence pool. Cactuses, no evidence. All right, so we'll move on to the specific experiment under debate. Alright, so there's two really simple experiments that physics has never done as far as I can tell. Okay, never found a paper, never found a video, never found anything talking about it. But you can use just a simple regular spring scale, okay, and you can measure how much something's velocity, you know, momentum. You can measure momentum with a scale, and you can sort of prove it. Okay, so you put something on the scale and it weighs a certain amount, and then you could drop it, okay, from different heights and see that it weighs. It has an instantaneous weight, okay. And what I've noticed is that it's about a centimeter. So a centimeter of height will double the weight of this battery. And if I take it 4 centimeters, I'll get double that, in the sense that I'll get twice the weight added, plus the weight of the object itself. So it's 3 times its weight. It's got its standing weight, it's got its 1 centimeter weight, and then it's got its 4 centimeter weight. So it's just 3 units of weight. And that's how it works. So the first centimeter, then 4 centimeters doubles, then 16 centimeters doubles, again, that velocity. And so you can understand exactly, you know, pretty much exactly how much speed will equal how much weight. And it works like as an idea really well. And so the principle is also the same for this. So I could, you know, have a pendulum bang into a spring scale, and it could show us what the velocity equivalent, and it's going to show you that what you're reading with the scale is actually momentum, that 1 mile an hour creates your gravitational weight, okay? Because now you don't weigh anything, right? If I do it this way, you weigh your gravity plus that. So if I do the 1 mile an hour thing, which is just dropping it a centimeter, it's 1 mile an hour, I can duplicate 1 mile an hour, and it's going to read the gravitational weight. So elephant, it'll weigh elephant, okay? Mouse, it'll weigh mouse. 1 mile an hour. So I'm just saying, a simple experiment, they haven't even bothered. And this is something you could do with a lot more better technology than it, you know. I got this in the garbage. I mean, it's just a fact. Okay, you can get some good stuff in the garbage. Anyway, it's, you know, I don't buy anything. Anyway, I'm poor. Anyway, so the truth is that's the physics. So the point is that, you know, these are arguments to be made. And, you know, if you really don't get that, then you're not going to get some of this understanding of the dynamics of these mechanisms, because these are just truths about how springs work. And Hooke's law is basically this, you know, that's the whole reason why you can have a spring that measures weight. It's because the rule is twice the weight, twice the deflection, 3 times the weight, 3 times the... That's the rule, okay? Within the spring's limitations, it'll do that kind of reliably. Now, the faster something's going, the more that's going to cause a spring some trouble, maybe. So there are rules, but basically the idea is that's how it works. Anyway, so this experiment done by this lunatic, it's all asshole, really. He's just an asshole. Who would even think to try this? Anyway, so he has a 25 mass, and so that came to 650 grams, all right, against a 1 mass, okay, dropped 25 times the height. Well, it's more than that, 4 centimeters versus 100 centimeters. So the idea is, as I just described, if we were going to think of 4 centimeters, we'd say that's 2 units, right? It's two units of an increase in your velocity. So if you're at 4 centimeters, you're doubling your momentum, plus there's going to be your weight. And so that's the 1950. That's what the spring is going to experience, is the doubled momentum, twice the speed, 2 units of velocity. The first unit makes you weigh 650. The second unit makes you weigh another 650. So you're weighing 2 units of 650. 2 units of velocity, 2 units of weight. So, and this one's actually going to be going 10. This one's going 2, this one will go 10. So it's going 5 times as fast. But there actually is 10 units if you start measuring it based on the 1 centimeter, then 4 centimeters, then 16 centimeters, then 64 centimeters, and then somewhere around 100. Okay, it's, a half of a division, a quarter of a division. So anyway, so the end result of the experiment. So that we're starting off with something that weighs 26 grams versus 650. So there's a 25 to 1 differential. And and this is going 5 times the velocity. So a 1 mass going 5 times the velocity, he says, equals a 25 mass going 1 velocity. And obviously if you put these things on a lever, right, a 25 mass at 1 unit of distance and a 1 mass at 5 units of distance, obviously you're not going to have anything close to the same momentum. This is going to be 5 times heavier. It's going to swing down, and that's it. It's not going to balance. It's not going to do any of that. So there's no chance these two things can make the same. They obviously can't make the same momentum. And the fact that you claim one of them has this kinetic energy doesn't just a claim. It doesn't mean anything. So anyway, he did the experiment and says, this is how the results he got. That the 1 mass going 5 velocity compressed the spring exactly the same amount as the 25 mass going 1 velocity. And the fact is, if you figure out its weight, its impact, its impulse weight, the impulse weight is 1950 for the 25 mass, and it's 285 for the 1 mass. So, 1 to 5 difference in terms of there's just no chance that this object could even balance this 1950, let alone give it velocity. I mean, no chance. If I did this on a lever where I set this 25 mass on the lever and it obviously tilted in this direction, and I dropped the 1 mass from a meter, it's just going to bounce. Because it's not going to get a chance to move that. If I crash them as pendulums into each other, there's no way the 1 mass is going to win. It's going to show it has 25 times the energy. It's going to get wiped out by the gigantic momentum of the 25 mass. So it's a silly outcome. Got to be just absolutely, there's obviously a mistake somewhere. Now, I noticed simple things. When he had the slow motion video, when I did a frame count, I got like 40 frames. For the same distance, I got 4 over here. So it seems this was going a bit slower than it should have been. So not exactly the right ratio of velocities. But who knows there were so many little flaws. The measurement device was absolute garbage. And, it's a junk experiment, and the outcome is so frickin' stupid. I mean, it's so beyond believable. His argument is that I could take a 1 mass and a 5 velocity. That is, I could take 285 momentums, okay, and compress a spring with that much momentum. Bang. small football player going moderately fast. Okay, and I'm going to be able to make a force significant to push gigantic football player. That somehow I could actually reverse this experiment, drop this, and launch this. That somehow you could literally drop a one mass just 5 distances on a lever and launch the 25 mass. No hope. No chance. No chance you could make 5 times the momentum. If free momentum was that simple, people would capitalize on it, because momentum does do work. It would just be silly for somebody to say momentum doesn't do work. Of course it does work. It's a force, essentially. That was Newton's statement. Force equals the momentum. You change the momentum, the force is the explanation. If your momentum increased by 10, well, you have 10 units of force. That's just the way it is. The force and the momentum are the same thing. So, just a silly garbage experiment. And they've been doing this for years. They produce these horrible experiments, and then my obligation is to show up and explain all the defects in the silly, stupid, rotten, crappy experiment. And I promised myself I wouldn't do it anymore, but I did end up getting dragged into it again. But this will just be a really great illustration of just how desperately bad the physics is, the science is, their logic is, their reasoning is. They will not pay any attention to stuff that just on its face can't make any sense, even to them. Free momentum, 5 times the momentum. I can't make free momentum. How can you people think free momentum is a real viable concept, and we haven't been able to take advantage of it anywhere? Not in electric turbines, not anywhere, nuclear power plants, any place. Is anybody ever talking about this idea? Well, why don't we just use the free momentum mechanism? Bang, let's just bang light things into heavy things and we can make all the free energy we need. It's really stupid. It's crazy is what it is. It's crazy. This is ludicrous that I have to make videos debunking crap this bad. Alright. So we'll read some comments. And I'll probably have to sacrifice the drawing eventually. And because I'll have stuff to add. Anyway. Alright. So the Dispars Lab asshole says, he makes a list of my complaints. So he says the top coil slipped into the thing that pushed the spring. So obviously when he dropped the 25 mass, the spring went inside the thing it's hitting. So, I mean, in some respects you say, well, that should be to its advantage. But, I mean, it just makes the whole experiment kind of garbage, because you're just saying, well, if the spring's going inside the object, then how the hell can you possibly, he's got a tape measure, 3 centimeters away to measure it with. How the hell are you getting an accurate reading if the spring went inside the damn mass you dropped? Alright, the one mass wobbled. Well, I brought that up just because the one mass fell. It seems like the whole, that it's, so it's running on a little steel bar. I could have drawn the bars, I suppose. Well, anyway, there's a steel bar. And the steel bar, okay, he's putting like a socket from a socket set on there, and it wobbles. So at least it's sort of free to fall. It's not much friction. And then the other thing, the big heavy mass, now it's really straight, no wobble in it, no nothing. So you're thinking it's probably the clearance between the hole and the steel rod is probably a lot closer tolerances. So you can understand there's probably a lot more drag because it's actually sticking a little bit to the metal rod as it falls. That's why that was brought up. Okay, seems a perfectly reasonable argument to make that if you're going to use these steel rods to keep things from going crooked, they should keep them from going crooked without creating very much friction. All right. By comparing the frames, it doesn't look like 5 times as fast, but faster. Yeah, well, I'm just saying, go ahead and do it yourself. This thing, you can't even see it moving as you're doing the frames. It's moving so much slower. And this one is doing, a centimeter in 4 frames. So, I mean, there does appear to be a huge difference. Yeah, it's 5 times the velocity. There should be a pretty big difference. But it looks more like 10 times the velocity. All right, bad camera angle. So this shouldn't be brought up. The fact is, if I look at it from down here, I'm going to get a different view because the objects themselves stick out and they're going to read a different number. The fact is, you're going to look at a tape measure. It should be directly straight with the tape measure. The thing you're measuring should be, you should be exactly parallel. It's insane. Perpendicular. Your camera should be perpendicular to the tape measure. All right, no quick release. So again, it's just so simple that, you know, all of these things, this, you know, this object's only going to drop 4 centimeters, and you stealing any part of that is going to take away a huge percentage of the distance it has to fall. And so, you know, letting things slip through your fingers doesn't work. I mean, I've done the experiments. I know it changes everything. Quick releases are really important. There's probably a better word for them. Frictionless releases. You really do have to create a mechanism that makes the difference between being held and being free, you know, as instantaneous as possible. All right, the ruler is far away from the experiment. Well, I mean, it's pretty important if you don't have a good measuring device. Yeah, it really sucks. So you really should have something that actually puts a mark on something, a little stick and clay. You know, there's Brozo is good at put a thread over the top of the thing, and then how much thread moves. Who knows? There's got to be a better way than having a crappy tape measure 3 inches away from the damn experiment. Okay, the spring is a piece of crap. Well, it is. Okay, so you're going to use the spring to collect energy. You want one that has the flat end, you know, where they've smashed the 2 coils together at both ends, so now it has a nice flat surface. You don't want one with the ends sticking up like this. Okay, that's not very reliable. Okay, let's just say. So, conclusion garbage. Yeah, and so what else is there to say? So these aren't reasonable critiques. The outcome is ludicrous. And you don't even pay attention to the superficial observations. I didn't analyze the whole thing very heavily because, again, it's not my job to play detective and figure out all the ways you fuck up. But it's a very bold claim you're making, okay, that I can make 5 times the momentum by just crashing something into a spring and replacing it with a heavy object. I can increase my momentum by 5 times. All right. So the idiot who did the experiment says, I know what a great analysis he provided. I know what a great analysis he provided. So again, it's just a mocking joke to them. The fact that the experiment is shitty, they just won't even account for that. He said the one mass was going 10 times the velocity, and he has question marks after it. Yeah, I'm just saying, a superficial observation of the frame rates, that's what it comes out to, yes. The thing that the fuckwit doesn't realize is this was my first run. So why publish an experiment that's garbage? So, and why would you do a first run without doing a lot of runs to see what exactly the experiment does do? You know, and how well your measurements are. I mean, why wouldn't you look at your own video and say, shit, that spring went inside the damn thing. That's a real fucking flaw. I mean, that's not my job. It's your job. You're going to publish an experiment and claim it proves something. Then damn it, you ought to take a little bit of care in how you do the fucking experiment. And that's why I've been saying that this all needs to be done by real clinicians. Okay? These assholes doing these experiments is not going to prove anything. Because you can't trust anything they do. All right. New apparatus is very rushed. Whose fault is that? And I wasn't rushing you, obviously. So rushed by who? So that's just so stupid. Because I have a life. Yes, a life doing what? Who the fuck goddamn knows? Unlike Goofy. I will do it again at some point. So that's what they all say. So Dispar never redid the knocking cartons over the right way. And as far as I can tell, he hasn't even done the spinning things with his motor thing by just moving the masses a little bit and seeing if the speed changes. Hasn't done any of that. and the other masses and height ratios, and will only get more improved. So promises, promises. All right. His little smirk at the end said it all. I know what he is saying isn't true. He knows what he's saying isn't true. So, I mean, I could swear on the souls of every person I've ever loved. There's nothing insincere in my arguments. I, for the life of me, can't understand why you accept the existence of this scalar energy that you can't see, that is, it's invisible, and it never shows up in the experiment either. So it never can be converted into work. So you claim it can do work, yet in every experiment where I say, please do some work, Mr. Kinetic Energy, it won't do any. I mean, amazing. It can't be caught in a ballistic pendulum. It can't move a rocket in space. It can't balance a lever. What the fuck can it do? I mean, really, it doesn't turn a water wheel. It doesn't turn an electric generator. It doesn't turn a motor. What the hell does this kinetic energy when does it actually do some work? It doesn't bend car fenders. It doesn't do a damn fucking thing, ever. All right. So he knows he is wrong. So just keep pretending you can make a moronic excuse like that. I'm doing this for no other reason than I think I'm wrong and I'm doing it anyway. I mean, do you really think I would waste 10 fucking years doing that? And I would be paying people to prove me wrong when I knew I was wrong? You are just so insipidly desperate. You fucking idiot. I say you're the one who knows that these are pretty good arguments I'm making, and you don't have a counter argument. You can't explain to me how I can't make the free energy device, right? With the simple experiment. 100 in, I get 200 out plus 50 back. You haven't explained how, oh yeah, that doesn't make any goddamn sense. I get half my fucking force back. The pendulum swings back up, and now I can smack again. And I sent 200 that way. So I doubled my momentum, plus I have even more stuff left over I can use again. You haven't explained how I can't make that device. You petty piece of shit. Okay. So all he has left is trolling. So amazing bullshit rhetoric. So anyway, so him and this crazy person, Sean Walker, spent 17,000 comments, 45 comments just talking gibberish back and forth. Nothing on the actual subject, pretty much. Well, I'd say nothing on the subject. And the only thing worth my trouble is there is a dispar comment. So we'll go find that. And I will dissect his rubbish. It just goes on and on and on in yourself. So Dispar says, I try to explain to Goofy that within an elastic collision, small versus heavy mass. So he made a 3-minute video where he explained absolutely nothing. All right, so, and he certainly didn't explain how I can't make a free energy device with all the free momentum he says I can make. That the kinetic energy says is clearly available. Anytime I want to just make a whole bunch of free momentum, it's as easy as hitting something, storing the energy with a light object, and releasing the energy with a heavy object, and I can make free momentum all day long. There is a certain point during the collision where the small mass comes to a full stop. In all collisions, yes, something's going to stop, but the key experiment that I've already explained is I could take 2 steel balls, okay, and you let them hit each other and then bounce, and they don't get hot. I can put a piece of paper between them, and the paper doesn't even hardly know anything happened. But if I take those same 2 steel balls at the same velocity, I smash them together, and I don't let them bounce away, the paper will burn. Clearly indicating that, yeah, it's not about, these elastic collisions. It's about a pressure being created, and if the pressure isn't relieved instantly, very quickly, then it's just heat, because it's just a bunch of electrons on the surface. So there's things that are obviously elastic, and there's things that aren't so obviously elastic. So I guess that's the I mean, obviously we call steel, hardened steel, very elastic, or glass. Glass is very elastic in a collision, okay? But it's not elastic in the same way that a rubber ball is or a spring is. But those things are also elastic. But you got to understand that, yeah, the elasticity's it's in a different form. One in large chemical, you could argue, the chemistry of rubber, and one is in just electrons and protons. So if I take two steel balls, you're not going to see the deformation when they hit. So when they hit each other, they crash into each other, you're not going to see anything getting bent. But a rubber ball hits the surface, and yeah, you get to see what happens. It flattens to the surface, its sides expand. All right, so you can see the fact that it's stored the energy, that it's collapsed, its surface has collapsed, and it's increased the pressure inside, or it's increased the pressure on the surface, depending on what kind of rubber ball it is. And there's a real rubber band effect where you can just see the stretched rubber band versus the unstretched rubber band. I mean, I got a rubber band here. You can see it, okay? You can see the elasticity. Well, you can't see the elasticity in the steel ball, but it's the same kind of elasticity. There's a point where it stops moving. Yeah, everything stops. So what? Doesn't mean there's no energy, right? Because we know we have it in these bands. And the same is true here. When these balls stop, their universe hasn't stopped. The universe right in here there's nothing stopped in here. There's a whole bunch of stuff still moving inside of there. And and it's all electrons. And so what it's basically saying is, if the object is the same mass, the electrons move and the whole atoms move with them. Okay. But if it's not the same mass, then the surface rejects the motion because the atoms can't move, because there's not enough force to move all the atoms. And so the rate at which the force moves through the object is the speed of its sound in the material. And the fact is that if it doesn't exceed that, it has to move the energy back again, so it just reflects. And it's a simple enough explanation. The energy of this object goes into this object and it freely moves, but if they're crashing into each other, then they're just going to exchange. This one's going to go this way with this one's energy, this one's going to go that way with that one's energy. But if they don't have a match in terms of their masses, well, then you're not going to get that effect. I guess that marker's had it. But, it's not playing games. When people start talking, oh, well, it's about the acceleration over a distance. There's no distance here. There's none of their silly math applies to this event, because this event is going to happen on the nuclear level. Electrons and protons are going to make these objects move apart and not move apart. Where here, you've got a bunch of, stretchy elastic. So you can see it. But the principle's the same. This is not coming back. If this surface that it hits moves, this is not coming back with the same velocity. Because obviously it's using some of its energy to move this object. And it can't possibly go this way with the same energy as if this doesn't move. I mean, it's so frickin' obvious. All right. So continue reading the mush. All right, there's a certain point during the collision where the small mass comes to a full stop before it bounces back, and therefore it must have zero momentum. So again, it's just silly to say there's zero momentum in the system. The system is rubber bands. It is real forces. The electrons and protons are doing this in the hard objects when they hit. The electrons and protons are doing lots of this, lots of action. You just can't see it, but it's the same action. Goofy replied that the momentum is of a stationary object can never be zero. I'm saying if you put momentum in, it has to come out as something. So it's either coming out as heat or motion. And that's your two choices. fundamentally. Sound, a few other things, but I mean, that's the only place you have to leak it somewhere. The momentum always has to go somewhere. So if you know you put momentum in, it's either stored in rubber bands, or it's heat, or it's motion. But you don't have much else to rely on. Okay. Because all the atoms inside the object are moving, vibrating. Well, I didn't say all of them. That's the whole point. The surface just makes the decision. In most cases, the decision is made when you push into the earth. The rest of the earth doesn't really know you pushed into it. You know, over there doesn't know, and over there doesn't know. The only part that knows is pretty much right underneath me. And it decides to push me back up in all directions with a certain amount of momentum. Of course, we know that the sum total of all atoms cancel out to zero momentum. So this is just more nonsense. You can't say you have a collision and then say there's zero momentum. It cancels out. It never cancels. But Goofy, of course, doesn't understand why it can cancel. I don't understand that being in any reasonable physics conversation where you could talk about destroying momentum. You can't destroy it. You can't create it, and you can't destroy it. That's why they say you have to conserve it. And again, it goes all the way back to Galileo, Descartes, and Newton that pretty much codified that conservation principle. I mean, Descartes most of all. I mean, that's pretty much the most important contribution Descartes made, was the recognition that these are numbers and you have to conserve the numbers. The universe has so much of it and it's always somewhere. Alright, this is just to say that he doesn't believe that zero velocity equals zero momentum. So again, I have no interest in playing some game that you're going to call something zero when you know you're going to be releasing it. So if it's the energy inside of an atom, this rubber band, you know, the tension inside the protons and electrons inside of an atom, and you're going to say, well, that's zero momentum, zero energy. Well, I'm going to say, no, we know it's releasable. We know all we have to do is break one of these bands and the whole thing flies apart and we get some bits out very fast. So we know the energy is locked into systems. All right, and you can release it. And then in some circumstances, we don't have to worry about any hidden stuff because we have linear motion, and we're going to transfer the linear motion. We know it transfers incredibly consistently. All right, so if I only have a certain momentum in the same mass, and I hit another mass of the same mass, it leaves with exactly the same amount of momentum because that's all there is. And the fact is I can't make more momentum by moving light things going fast into heavy things. I can't make free momentum. And I clearly can't conserve any notion of kinetic energy. And I clearly can't make energy going this way and that way that cancels. Because then I could always just put the energy this way with a cue ball, hit two billiard balls, move them this way and that way equally, and somehow you're going to argue I didn't have to use any of this momentum. This ball goes the same speed, and those things leave because they cancel. There's no such thing as cancel. It has to go this way, and it has to go that way. It has to turn right, and then it has to turn left, and it has to turn right, and it has to turn left. It can't just say, oh, we're not going to do either one. Just as we have to push into the earth for the earth to push us back up, okay? It's not canceling energy. There's not a force the earth is pushing and then we're pushing. The two forces just magically cancel. No, we have to actually push into the earth and then the earth has to push us back. You idiot. Moron. Fool. Dupe. Potty mouth retard. Okay, so the rest of these assholes are not anywhere near the subject. So, Brozo says, very impressive demonstration, Michael. Thank you for making this effort. Pity it will be ignored or trashed with feeble excuses. So what are you going to say? You know, I'm just saying, so when somebody else demonstrates, okay, with some other counter experiment or some experiment that's close to this, that clearly demonstrates that there's no possible way, okay, that, 285 newtons cannot equal 1950 newtons. Those two things can't do the same amount of work. It's impossible, and you can't make one out of the other. Going this way you could, but you can't do it going that way. Okay, you're not going to make 1950 newtons worth of motion in the universe, pressure, out of 285 newtons going in. You can't put 285 in and get 1950 out. It's ridiculous. It's idiotic. I should not have to argue this flat earth crap. Alright, but these people sustain each other. They support each other in every little silly, crappy, nonsense endeavor. In the name of defending science. These are the science defenders. You talk about science doesn't need a, this is their worst enemy, is their advocates. Alright. That's probably enough. Let me think. Is it enough? Maybe I'll think by myself for a minute. Yeah, all by myself, without you people. You're just irritating. Oh, yeah, I did forget there's a comment on my website by Coca Nuts. Shit. Why do you think momentum is something a scale can measure? Because it makes perfect good sense. It's like tackling dummies or all kinds of different mechanisms an athlete might use to measure performance. It makes perfect good sense. There's a big problem with that, says you. Alright, if one mass going 2v and a two mass going 1v hit a spring, you think they will compress the spring the same amount. Yes, it just matters about how much momentum. If the momentum's the same, the compression will be the same because momentum is weight. Alright, so this is the whole video. This is a video actually says that, right? Let's see, this is the kinetic energy is, okay, so if you watch the video before that one, it was called weight is momentum. Alright, anyway, that means that one mass going 2v travels the compression distance in half the time in comparison to the two mass going 1v. So again, he's arguing as if there's some kind of compression time or compression anything when two steel balls hit each other, and there clearly isn't. So playing some game that you're going to measure how fast the spring crushes or how slow it crushes, you don't have any evidence that it makes any damn difference to the spring. Alright, during the time it loses twice the amount of velocity, which means it loses its velocity 4 times as fast. Says you, it can't lose anything. It's all energy, it's momentum, it's motion of matter, okay? Mass is moving. The spring is going to end up being mass moving, okay? And the mass moving is going to transfer the mass moving into a bunch of stressed steel. Okay, shouldn't it be twice as easy to slow down the one mass compared to the two mass? So again, depends on how stiff the spring is, all these things. So it's just a kind of a nonsense statement that it makes any difference how fast or slow it does its accelerating or decelerating. Obviously on a lever, you'll get a perfect proportion. Obviously two distances on the lever is automatically going to be twice the velocity, so no problem. You decelerate an object that's twice the mass, it decelerates on one side at exactly the same speed it would decelerate if there was a 2 mass on the other side. So I can drop a 2 mass and lift a 2 mass, and the deceleration will match the acceleration. But the truth is, I put the 1 mass, 2 units of distance, I'll get exactly the same deceleration out of the 2 mass, and I'll have twice the acceleration of the 1 mass. So there's no problem. Alright, can you explain why would the 1 mass going 2v lose its velocity 4 times as fast if the spring applies the same resistance to both objects? Well, obviously how the spring is absorbing the energy, okay, you're saying it absorbs at the same rate no matter how fast something hits it. I'm saying, of course it doesn't have to do that. It absorbs at a different rate. Okay, or why would the resistance be larger for the 1 mass and 2v? It's an amount of energy, so it's like absorbing it as friction. You're just arguing that essentially the spring is going to take the energy from the object. The object's going at velocity, it's going to interact with the spring is going to deform and do all kinds of weird shit, okay, as it gets this imposition of pressure upon it. And so all you're doing is converting that pressure. And the spring, by Hooke's law, has proved itself relatively reliable at doing this thing. So why would you question the fact that you're taking the energy away from the object and you're putting it into the stress of the spring? It just doesn't make any difference how fast or slow it does that. All right. Stupid comments. This other guy said a whole bunch of shit, but I don't understand one word of it. Could one say moving 1890 to 1910 from DC vector-based? This isn't really about, Edison and Tesla, so not terribly interesting. Sorry. Anyway, and obviously this kinetic energy thing is a real 1850 kind of thing. That's when they really started forcing this to be the issue, claiming the vis visa was real. I mean, Joule actually used the words vis visa. So did Lord Kelvin. Eek. Ooh. Creepy. Alright, anyway. So enough of this. So that should be enough of a video. So till the next time and such and so forth and whatnot. If I wasn't watching these videos and seeing this whole thing happen, I would say it was impossible. There's no way scientists could be this dishonest, that this whole thing could be such a fraud. No fucking way. But here I am. I'm watching it, saying, holy shit. I can't believe it. It really is incredible. So I did find that one person one time. I found one guy has a website where he says kinetic energy is garbage. And so I emailed him, and tried to say, hey, look, we have a common, but we don't have a common. Because I think he thinks it's cubed instead of squared. I think he thinks it's cubed or some other kind of wacky shit. Just funny. Just hilarious even. It's just so silly that you find one person that actually gets it, that it's wrong, and you can't even there's nothing. There's just no motivation to fix anything. Just leave the world broken. It's your moronic philosophies, and it's moronic, frankly. It's evil is what it is. Like I said, this is Steve Mould's video is a piece of lead paint served up to children. It's a junk, horrible pile of crap science. It should be mocked and ridiculed. It should be driven off the internet. You should redo the video right instead of creating a bunch of fake and phony notions that just aren't fucking factually defendable. Alright. Till the next time and such and so forth and whatnot.